Your Cornell notes for this video should be set up this way and have the title 5-6, Parallel and Perpendicular Lines. How can you identify parallel lines? We're going to answer this question in this video. I'm going to show you a few slides of seeing parallel lines out in the world, and I can also show you how to identify parallel lines looking at equations. Let's start with looking at parallel lines in the world. Here you see we have parallel lines on railroad tracks. We see parallel lines on buildings, even on our food that we eat. There are parallel lines on instruments, and we use parallel lines for sport fields. You can also refer to parallel lines to give directions from building to building. Here is a situation of a farmer market's fee represented by a graph, and we're just going to discuss what parallel lines are. But before we do that, let's understand what farmer's market is. Farmer's market is a food market at which local farmers sell fruit and vegetables and often meat, cheese, and bakery products directly to the consumer. There's a really great one in Pasadena that I love to go to, and I get eggs from that place. So this represents the fees that the people have to pay in order to go there to sell their product. And they have the different fees set up, and it tells you what the red and blue line represent. But I don't want to focus on that. I want to focus on looking at the slope. You can see that these two lines are parallel, and we looked at an example of parallel lines on the previous slide. These two examples are parallel, and notice their slope. Both of the slopes are the same. So when you have parallel lines, your slope is always going to be same slope. Slope is the same. Okay? For parallel lines. Identify which lines are parallel. We have two columns of equations, and we're going to go ahead and match them and see which ones are parallel to each other. Remember, parallel lines have the same slope, and these lines are in slope-intercept form and point-slope form, which you've had experience working with both now. So let's look at the first column. We'll call this problem number 1. The slope here is always in front of x, so our slope for this problem is m equals -5/6. For equation number 2, our slope is 1. Equation number 3, our slope is 3. Remember, it's always next to the x term that gives us a slope. For number 4, it's y equals a number, and that is a horizontal line, so our slope is 0. Number 5, our slope is -1. And number 6, our slope, which is right next to x, is 1/2. You can't really see that. That's okay. Slope is 1/2. Let's look at the other row. We'll label these as A, B, and C. This is x equals a number, which means our slope is undefined. B, we have our slope is going to, if we distribute the -1 here and here, our slope is going to be -1. C, this is a horizontal line, so our slope is 0. D, our slope is 3. E, our slope is 1/2. And F, our slope is -5/6. So let's identify which ones are the same. And I'll actually need, we'll use a red color, and I'll use a thicker pen. So you can see that. So we're just going to identify them by drawing a line across. For number 1, our slope is -5/6. And if you look to the right-hand side, F is also -5/6. So those two lines are parallel. Number 2, our slope is 1. And we actually don't have 1 as our slope anywhere. So number 2 does not have a parallel line. Number 3 is 3. Our slope is 3, and so is D. Number 4, we have slope equal to 0. So number 4 is going to go with C. Now I want you to go ahead and match up 5 and 6 on your own. If you have any questions, bring those to class tomorrow and we'll discuss them together. And make sure that you rewatch the video if it was difficult, and make sure you pause and rewind to get the concepts. Okay? See you in class.